Hey guys, some of you liked the journeys to Mars or Venus, so my proposal today is to take you to another ride in space and travel to the sun to discover what it is made of and how it works. As you know, life would be impossible on Earth without the energy that the sun sends us under the form of heat and light. And for that reason, because it determined the days and nights, the seasons, the years, it was given a particular importance and meaning in every civilization in history. But let's take off to the sun, which is going to last about 8 minutes, because we will travel at the speed of light, and 8 minutes is the time necessary for light to travel between the sun and our planet. And during these 8 minutes, I'm going to tell you about the history of how the sun was perceived by man and how it moves in our galaxy. As I said, the sun was given a particular importance in every civilization, and the most common conception, be it in Asia or in the Mediterranean world, or for the pre-Columbian civilizations too, was that the Earth was the center of the world. Most of the time it was believed that the Earth was flat and that the sun was moving in the sky, or was like a planet, a particular planet turning around the Earth. When scientists, scholars, started to question this conception of the universe, they were often rejected by their peers and by the society, because it was frightening to attack the conception of the universe that these societies had. And there are several examples of that. For example, the Greek philosopher Anaxagoras, who had the idea that the sun could be moving in the sky and turning around the Earth, and for this he was rejected and even had to leave Athens, rejected by his peers. Another example is Copernic, a Polish scholar who developed the theory called heliocentric. Helios is the sun in Greek, because his theory was that the Earth was only a planet turning, revolving around the sun being the center of the universe. And this theory, which was not entirely true, but much closer to the truth than past conceptions, was also attacked, condemned by the Christian church in particular. However, in the 16th and 17th centuries, the observation and the beginning of a scientific method allowed to better understand how the solar system was working. And by the middle of the 17th century, French philosopher and scholar Descartes had the idea that the sun could only be one star among others in the universe, another important step on the road towards understanding what the sun could be. The observation and scientific progress in the 19th and 20th century permitted to much better understand what the sun was and how it was functioning. Sometimes we have the temptation to consider the sun as the center of everything, because it is the center of the solar system. But in fact, the sun is just one star among billions of stars in our galaxy, the Milky Way, and our galaxy itself is just one galaxy among billions of galaxies in the universe. And the sun is not even a very large star. There are stars that are much bigger than it, sometimes up to 20 billion times bigger than the sun. And there are also stars that are much smaller, down to 1,000 times smaller than the sun. And the sun is not staying all the time at the same place. It is moving too, and like all the stars in the Milky Way, it is revolving around the center of our galaxy. It takes millions of years for the sun to make a complete revolution in the galaxy, because the distances are gigantic. But the sun, in a sense, also is like every planet of the solar system, like a satellite turning around the center of our galaxy. However, seen from the center of the galaxy, the Sun would be the main element and maybe the only relevant one in the solar system, because it represents more than 99% of the quantity of matter in the solar system. All the planets, including the Earth, are almost like small particles of dust orbiting around the Sun, which is much bigger. If the Sun was a basketball, for example, the Earth would be no bigger than a pinhead in comparison. But we are now approaching the Sun, and a first observation we can make is that the Sun has no precise surface. It is like a ball of gas floating in space with an extremely hot core where reactions of fusion take place. I will elaborate on this in a minute. And around this core are various layers in which the radiations coming from the core diminish, and generally what we call the Sun, the limits of the Sun, is a layer called the photosphere, that is the last visible layer that distinguishes the Sun in the obscurity of space. But the radiations sent by the core of the Sun continue to radiate much further. The energy produced by the core of the Sun is called fusion. This is made possible by the composition of the Sun, which, like every star, is made primarily of hydrogen. Atoms of hydrogen are the simplest atoms that can be found in the universe. They have a very simple core made of one proton and one electron revolving around this core. About 3/4 of the mass of the Sun is made of hydrogen, and in certain conditions of heat and pressure, conditions that can be found in the core of the Sun, atoms of hydrogen can merge together and give birth to other atoms essentially atoms of helium, another common kind of atom in the universe because it is produced in great quantity by the stars. And these atoms of helium have two protons in their core as they result from the merger of atoms of hydrogen or the fusion of atoms of hydrogen. Sometimes there is a confusion between this fusion reaction that takes place in the Sun and liberates incredible quantities of energy under the form of light and heat, with the reaction that takes place in nuclear reactors we have on Earth. But the reaction is fairly different. In a nuclear reactor, the reaction is that big atoms of uranium and plutonium are being broken. They are bombed with other particles, and the breaking of these atoms liberates energy. In the case of the fusion energy, it is the merger of atoms that creates this energy, and it requires a much bigger inflow of energy to take place, because it requires to break the forces that maintain separated the atoms. And maybe one day, because it is still technically impossible today, it could be possible on Earth to control this fusion reaction, to produce a very abundant and cheap source of energy. But the know-how to control this reaction remains out of reach for now. The creation of energy in the Sun turns incredible quantities of hydrogen into helium, and bit by bit the Sun is consuming its reserves of hydrogen. Actually, millions of tons of hydrogen are consumed every second, but the core of the Sun works like a self-regulated reactor. When the reaction of fusion tends to accelerate, when more atoms of hydrogen are merging, the core tends to grow bigger, and by growing bigger it cools down a little bit, which slows down the reaction and help maintain it more or less stable with this alternance of inflation and deflation of the core. like every star, the sun will not be eternal. One day it will run out of hydrogen, and the reaction of fusion will slow down and stop eventually. But given its reserves, it is estimated that the Sun still has several billion years of fusion, more or less stable, ahead of him. And given that this star appeared a bit less than 5 billion years ago, it is considered to be in the middle of its life. When the Sun runs out of hydrogen, it could turn into what scientists call a supernova. The superficial layers of the Sun will not be maintained in place anymore by the force of gravitation, because the core will contract, and this will increase the quantity of energy rejected by the Sun, and will allow its layers to inflate dramatically, absorbing probably Mercury and Venus, and the surface of the Sun would almost reach the Earth, turning our planet into a completely dry desert. But this should not happen before another 5 billion years, so we can rest assured that the Sun will continue to rise and make life possible for us. As we are now going back to Earth, I would like to draw your attention to the fact that the Sun is just one star among billions in our galaxy, that there are billions of galaxies, and so that the chances, the probabilities to see life as we know it appear on planets, because there are hundreds, thousands of billions of planets in the universe, are extremely high, even though the probability of seeing life appear on a given planet is low. This low probability multiplied by these thousands of billions of planets mean that it is highly likely that other beings occupy the universe. We are now coming back to our planet, and once again I hope you enjoyed this little trip to space, and I hope to see you soon. Bye bye.